All right, Algebra 2, welcome back, guys. We are jumping into section 7 here, titled Function Notation. So everybody make sure you have your books open to page 51, just as it says right there. And we're going to hit the ground running, okay? One thing right off the bat, I do want to specify, there's a lot of you guys that need to be taking these notes, okay? So I'm basing this off of what you're getting on some of your homework assignments. So make sure that every single one of you guys are watching these videos. Some of you really need to be paying extremely close attention, so please do that. And I understand, I get it. You may not want to watch these videos more than once, but it might be greatly beneficial for some of you, okay? So take advantage of it. These videos are online. You can watch them as many times as you need to, pause them, rewind them, all the normal things I've always said. But trust me, some of us need to be doing more of it. All right, so there you go. Here we have it. 3 key terms. That is one of the first things you're going to notice. Remember, all the key terms are always highlighted in yellow. Find those, write those down. They're going to come up in the homework. They're going to be at the test. I could use the words, and you have to understand every single one of them. All right, next thing to go into here is, what does that little phrase mean? It means f of x. Okay, so you're going to see the letter f and then parentheses and an x inside of it. Just means f of x. That is called function notation. Okay, and so basically what we're doing here is anything that they put in those parentheses in place of x, that's what you're going to have to put for every x value in the equation. Okay, so they could give you multiple different values for that x in the parentheses, and that means you're going to have multiple answers. Okay, let's see what that means. Quick example right there. What if they replace the x with a 2? So follow those blue arrows, and that means you're going to replace the x squared with a 2. You're going to replace the other x next to the negative 4 with a 2. Do that. You'll see the quick little work there down at the bottom, and you would get an answer of negative 4. 2 squared is 4. 4 times 2 is 8. 4 minus 8, negative 4. Okay, so there's that. And I pretty much already said this, but if you have multiple values that they give you for x, so they could say f of 2, f of 0, f of 1/2, and they could just keep going, you're going to have an answer for every single x value that they give you, okay? And then when you're graphing, basically think of f of x as y. So whatever is in that f of x, treat that like your y value, so you know what to do for your y-axis when you are graphing. All right, now one of the last notes we have here, y is also known as your dependent variable, and x is known as your independent variable. And let me quickly explain what that means. Independent means that this is what they're giving you. All right, you can't control that. That's independent of anything that you have control over. That independent variable, though, will control the value of y. So in other words, that is why y is dependent upon the independent variable. Okay, so there's that. That's a little bit of kind of a connection with science, because when you're doing graphs for like physical science or chemistry and so forth, then you could wonder like, okay, what's my independent variable? And you're adding something to a solution, and then the dependent variable upon the reaction that you get from it, and so forth. All right, let's keep moving. Example problems. All right, some of these example problems, I've started to work them out. Wanted to save you guys some time. So everything that's written in black is what would be given. Anything in another color is part of the work. Okay, so you see we have 3 different f of x values. You got f of 0, f of 1/2, and f of negative 2. And you see those arrows right there basically say, hey, all of these values will be going in for x. Not at the same time, of course, but you will then have 3 different answers. Okay, so if we were to plug in 0 first, you're going to have negative 2 times 0, add 1. We figure that one out. That's going to be 0 plus 1. It's 1. So one of your answers is 1. All right. Then plug in 1/2, negative 2. I'm going to put it over 1. Just makes life a little easier here. That way you can see what we're looking at. So negative 2 times a half, that's actually going to be a negative 1 plus 1, just 0. Okay, so there's that. And the final one here, a negative 2 times another negative 2, add 1. That's going to be a positive 4, add 1, and get 5. Okay, simple enough. Basic algebra, plug it in, get the answer, move on. All right, speaking of moving on, I've worked all of 2A out for you. So I'm just going to give you just a quick run through. Okay, again, everything that's written in black there, 2A, that's the example. Then you have a mapping. Okay, so you remember that from previous assignments. Everything on top would be your X. Everything on the bottom is going to be your Y. And follow those little lines. I wrote in, remember everything in another color, I wrote in there. So that means that 3 goes with 2, 5 with 6, 7 and 9 go with 10, both of those, okay? So then you'll notice you actually have 4 points, even though you have 3 Y values, because you're gonna have a double 10 value, all right? Now, I did write in the little 1, 2, 3, and 4 next to each of those ordered pairs, just so that it would help you to see them a little clearer on the graph. And all they ask you to do is graph it. So in the directions for 2A, just to make sure that you guys are tracking with me, I'm on page 52, okay? That way you can see where I got this work. Then you have to create the graph, plot the points, and that's it. Okay, simple enough. I put the little 1, 2, 3, 4 just so that it's easier to tell where the ordered pairs are. That's all you got to do. Okay, let's scroll and take a look at 2B. What they give you here is the function f of x equals 2x plus 1. That's what's given. Little review there written in red. The 2 is your slope. Okay, remember the format. I'm going to add this little part here. Actually, I'll write it in blue. Remember mx plus b. Everybody should remember that. That's called slope-intercept format. And the value of 2 is where the slope is. So you know 2 is your slope. And the value of 1 is where the y-intercept is. So now you know what your y-intercept should be. And then off to the side there, you'll see 2 over 1, because your slope should actually always represent both the rise divided by the run. Okay? And I make sure to always have 3 dots or 3 clear points. All right? The first point is going to be the y-intercept. What does the y-intercept mean? It means where it touches and or crosses the y-axis. And remember that that is your y-axis. That is your x-axis. Okay? So the 1, we plotted that. There's the green dot. We went up 1. Boom. There's the dot. From that dot, so from 1, we use the slope. So we go up 2 and then right 1. That's going to be our second green dot. And then because we know the slope's never going to change, from the second green dot, go up 2, right 1, plug in that third dot. So clearly we have a very well-defined graph. There's those 3 dots. Okay, good, good. Let's move on. All right, so now we have some stuff we got to write in, because 3A and 3B, everybody go to page 53. Okay, we got to do a little bit of reading here. It's a word problem. Okay, so what we have, a local photo shop will develop and print the photos from a disposable camera for 27 cents per print. Okay, for 3A, they want us to write the function to represent the cost of photo processing. Big old fancy words. All that means is, what's the equation that represents 27 cents per print? That's it, okay? So how do we write that? We know that each picture costs 27 cents per print. Okay, well then let's just put the variable p right next to it, and that represents the per print. We're done. That means 27 cents every time you want to print a picture. So whatever value you put in for p, that's the quantity of prints. If you wanted to print 50 pictures, you do 0.27 times 50. So whatever p is, that's the number of pictures multiplied by 27 cents every single time you're going to do a print. So that's how you're going to do for 3A. Take a look at 3B. What's the value of the function for an input of 24? Okay, they want 24 pictures. 27 cents times 24. Let's make life easy here. Plug that into your calculator. All right. That's going to give you the quantity, sorry, not quantity, the cost of 24 prints. And you should get $6.48. All right. Boom. That's it. Okay, last one we're going to do here. Turn the page, go to page 54. We're going to do an actual homework question. Number 15. I just wanted to show you this because none of the example problems look like number 15. So that way, hopefully we can understand it. They're going to give you all those f of x values. So if you're taking a look at the book here, you got f of 0, f of 3 over 2, and f of negative 1. Okay, so f of 0, f of 3 over 2, and f of negative 1. But they don't give you an equation. So there's no function here. They give you the graph. So all of these values are your x values. Okay, right? We remember that. So f of x, but we just replaced it with a number. So on the graph, you're going to go to x is 0 and then figure out what is y when x is 0. So take a look at 15. When x is 0, y is a positive 2. So we know the answer to that one. It's 2. Okay, now go to where x is 3 over 2. 3 over 2 is the same thing as 1.5. So go to the right one time and then go half and go straight up. And what are you hitting on the y-axis? 5. That's exactly what you're hitting. And then go to where x is negative 1. So go left one time from 0. And what do you hit? Well, you don't go anywhere. You hit 0. That's exactly where that dot would cross. Okay? That's what I got for you guys. All right. I hope you have a great morning, afternoon, evening, whenever you're watching this. Okay? Watch it twice. It won't hurt you. All right. See you guys in the next one.